Okay, so welcome back to Math Partake. Today we're going to be working on a proof for geometry. The example that we have here says, prove that if the line segment KM and the line segment JN bisect each other, then the triangle JKL and the triangle NML meet the side angle side criteria, and the distance from J to K is equal to the distance from M to N. And then you also have this image here. The image shows two triangles. You have triangle KLJ, and then you have triangle MLN. Okay. And if you look at them close enough, you can tell that they're probably equal, but we do have to prove it. So let's get started. The first thing that I like to do for these type of examples is I'm going to write something called a given and a show. So when you write your given and your show, you want to start off with what was placed behind the if statement. So I'm going to write given. Okay. And my given statement is right behind the if statement. So line segment KM and line segment JN bisect each other. And that's all you need for your given statement. Now for your show statement, which I'll write, let's skip a line and write it here. Your show statement you can find in your example right behind the then statement. So it says then the triangle JKL and the triangle NLM meet the side angle side criteria, and the distance between J and K equal the distance between M and N. So, and that's all written right here. So what I'm going to do is I'm not going to put the side angle side part. I'm just going to put the distance between J and K equals the distance between M and N, because I'm actually going to find side angle side before I find these distances. Okay. So I'm just going to put that distance between J and K is equal to the distance between M and N. Okay. And that comes from right here. So that's our given and our show. Let's move on to the first step of our proof. So step number 1 of the proof. And let me just write proof at the top. Some teachers look for that. So step 1 of the proof. We're going to actually reiterate our given statement. Our given statement is that the line segment KM and the line segment JN bisect each other. Okay. And our justification, which you should be putting on all your proofs, is that this is the given statement. Okay. Anytime you write a direct proof, which is what we're doing right here, your first step is always going to be rewriting the given statement. Okay. So here I'm just going to write my justification as by given, and that's enough. Let's look at step number 2. So when we look at step number 2, we have to use what we have received from step number 1, which is our given. And it says that KM and JM bisect each other. So this is KM, this line here, and this is JN, this line here. And it's saying that they bisect each other. Now this is a quick definition alert. Okay, you may want to write this down on the side. The word bisect just simply means to divide into 2 equal parts. Okay, so they're saying that this line divides this line into 2 equal parts, and this line divides this line into 2 equal parts. And they intersect right there at L. That's where they bisect each other into 2 equal parts. So when 2 lines intersect and they bisect each other in this way, what you have is something called a midpoint, and that midpoint is L right here. So when you look at the line KM and you see that it's bisecting JN into 2 equal parts, then you can say, well, JL is equal to ln. Okay? And then this line, Jn, bisects Km into two equal parts. So that means that this line of Lm is equal to this line of Lk. Now keep in mind, these are two separate triangles. These are two different triangles, but we're trying to find out if they're congruent and if certain sides equal each other. We still want to prove that this distance equals this distance, okay? That this side equals this side, okay? So let's move from there. Step 2, we're just gonna work off of this word bisect, which we just shown here, and we're going to write it down in a proof format, all right? So we saw that NL equals JL. So let's write that down. Line segment NL equals line segment JL. Or we can put the distance is equal to each other, either or. We can also say that line segment ML is equal to line segment KL. And this justification is by the definition, I'll just write def for short, of bisector. Okay, remember, bisector, bisect. Let's move on to step number 3. Now here goes another definition alert, or we could even say theorem alert. And that theorem is the vertical angle theorem. This is what we're getting ready to use. I want you to recognize what's going on here. So the vertical angle theorem says that vertical angles that are opposite of each other and formed by two intersecting straight lines are congruent. So ask yourself, do we have that here? Yeah, we actually do. We have two straight lines, okay, that we just talked about, Km and Jn, straight lines, they intersect at L, okay, and then you have two triangles here. Vertical angle theorem comes into play. You can definitely say that angle MLN is equivalent, is congruent to angle JLK. Those are two equal angles. So let's write that down in our proof format. The measure of angle KLJ is equal to the measure of angle MLN. And this is by what we just talked about, the vertical angles theorem. So now we see we have two triangles. This side is equal to this side. This side is equal to this side. And then we have an angle that's equal to another angle. So in geometry, we call this side, angle, side. All right. So because we have two triangles that share the same distance in two sides and share the same measure in one angle, we can use side, angle, side as a justification to say that these two triangles are actually congruent. They're actually the same. Let's put that in the proof. So, triangle KLJ is congruent to triangle MLN. And this is by side, angle, side. By side, angle, side. A lot of people like to say SAS. So now we're approaching our fifth and final step. And before we go to our last step, I'd just like to say, if you are enjoying this video, if it is helping you, please make sure that you press the like button and subscribe to this channel so you can receive more videos that'll help you just like this one. So now that we know that this triangle is equal to this triangle, they're exactly the same, we can definitely look at what we need to show, which is right here. The distance between J and K is equal to the distance between M and N. This is J and K. This is M and N. If the triangles are the same, we already know these two sides are the same. There's only one side left. That has to be equal. So we can just write that in our proof. We can write that the distance from J to K is equal to the distance from N to M. Excuse me, from M to N. And this justification is just by the corresponding sides of congruent triangles. We just use symbols for short. And that's the final step of your proof. I hope it makes sense. I hope this helps you out. And I hope to see you next time on Math Partake. Hey, thanks for watching. For more answers and help that you may need in math, subscribe to Math Partake.